Hello, everyone. Welcome to the International Day of Women in Statistics and Data Science 2025. I'm Wendy Plata, and I send greetings from Ecuador. Thanks for joining this fourth annual of the International Day of Women in Statistics and Data Science conference with this year's theme, Thriving in Your Environment. We are recording this event and the videos will be available on the Caucus for Women in Statistics YouTube channel. We kindly ask you to post your questions to the speakers in the Q&A chat. Without further ado, I am delighted to host this session 201, Statistics Without Boundaries, uniting classical methods with artificial intelligence, machine learning, and data science. Let me introduce myself as first speaker. This is me, Wendy Plata. I am computer science and master in productivity and quality management. I study at Spot University, and I have more than 20 years of experience in process, statistics, and education, leading initiatives that combines technology, quality, and organizational well-being. And nowadays, I work as CEO of Silver Quality Consulting. It's a firm specialized in quality and productivity and organizational well-being across Latin America. And it's a pleasure for me to be in this event. Thank you so much for having me. And today I would like to share with you the topic from data to insight, leveraging generative artificial intelligence for analytics. And I would like to start with this question. Will artificial intelligence take my job? Please answer in the chat. I would like to participate with you in the chat, and I really appreciate your answers. Will artificial intelligence take my job? This is the question that probably is always in your mind, in our minds, because obviously we are thinking about how artificial intelligence is helping us with a lot of tasks. But what is the real situation? Is the artificial intelligence taking our jobs or not? Thank you for your very good questions. Yeah, your answers. Thank you so much. I hope no, Meredith, thank you. No, it would complement, would not take my job. Very good, very good, very good answers. Thank you for sharing. Okay, very good. But as an introduction, I would like to say that generative AI is redefining how organizations extract insights from data. Of course, the integration of AI-powered tools enhance decision-making through automations and intelligence, exploring the synergy between data science, machine learning, and generative AI for advanced analytics. If we focus on this kind of AI-powered tools, we're going to explore this synergy between data science and machine learning with artificial intelligence. And what are the core components of generative AI in analytics? First of all, we need to understand the data, because sometimes we don't have the enough experience about coding or about computer engineering or about programming. And this is very important that we understand the data. And if we don't have this ability, prompt engineering is a good choice in order to embrace the artificial intelligence. Prompt engineering, it's prompt are the instructions that we give to the artificial intelligence. And prompt engineering is the the things that we do when we design and polish those kind of instructions to make it more efficient to get better outcomes. And the another thing is that with generative AI in analytics, we can automated statistical analysis without being a lot or several times with another tools. I have the experience with group of sales department where we spend at least 4 hours doing a statistical analysis from the scratch because they didn't have the knowledge about statistics. But the theoretical part was not the problem. The problem was that they didn't have the ability to use the software properly. However, in the last class, we only spent 15 minutes to do a statistical report about descriptive statistics. And it was very interesting how they could leverage their analysis when they knew the theoretical part and then they apply artificial intelligence, in this case, prompt engineering. With the appropriate prompt, they got the results very quickly. And another core component is model generation and interpretation. I am using the artificial intelligence with this kind of interpretations. In fact, in machine learning, I am starting some research and I am exploring new models and I am asking artificial intelligence how to interpret this kind of results, even though I am not an expert in that model, but those are my baby steps. And of course, definitely for decision-making augmentation. This is a case study in sales. And first of all, we have here a dataset about sales. And the simple question that you can start today, what is this data about? What is this data about? No more. And if you do that, show how the artificial intelligence, in this case, I am using ChatGPT model 5, and I am using this, and you can see here how the data is loaded, yeah? And then you can ask for more analysis. Look at this, the description and the data understanding that that I told you before. Even though the variables are in Spanish, as I made the prompt in English, the description and the communication is totally in English. And here you are a description of each variable, even though you maybe don't know what is data about in advance. And here the artificial intelligence gives you some ideas for analysis, like multiple linear regression, predictive analysis, or business intelligence dashboard. And you know, this artificial intelligence is very proactive. And in this case, you can see here, if you would like to do or create a quick exploratory analysis, of course, yes. And look at this, we have here the mean, the standard deviation, the mean, and some quartiles, you know, here, and we have an idea about the data. And it is very interesting that, as previously, the artificial intelligence suggested the correlation matrix. Here you are, the correlation matrix, and you can see very nice graphs, a very nice scheme about correlations. Yeah, Let me know in the chat if you are finding this useful for your previous analysis, your exploratory analysis. From 1 to 10, tell me in the chat if you are really finding some insight for your analysis. And here you are, for example, the highest correlations between advertising and sales, 0.58, and the stock with sales 0.66. Yeah. And another graph that we can see is scatter plot. You can see here that as correlations are highest, you can find this kind of chart with artificial intelligence. Only without a very structured prompt, only with the natural conversation, I mean natural language. And this is the key. This is the key where we are going to make the difference. We're going to make the difference if we use prompt engineering. And the key is that we give the artificial intelligence a role. In this case, I gave the role like statistics expert. I encourage you to do a screenshot of this image and try this prompt, and you can polish this prompt and you can ask, for example, frequency table graph measures of central tendency and dispersion on something related to this. Yeah, and the most important thing is the technical interpretation of results, but we need to have a theoretical background about statistics in order to understand the interpretations and distinguish what is true, because you know what is true and what is false, because you know that artificial intelligence makes mistakes. Another conversational or natural language uses is to ask for multiple linear regression model. And here we are a multiple linear regression model predicting sales in thousands of dollars. And obviously we got R square close to 1, but it's very important to understand what are the limitations about this kind of analysis. What is the limitation of data, and what we need to check in advance. And artificial intelligence enables the generation of code in R and Python for use in data science. If you want this code, you can follow me and ask me for this code. Of course, I would like to share with you the code in Python. And in order to do clustering analysis using the k-means analysis, is that you have the code here and you have a data, random data, and the code is based on this, and then you can use your own data in order to repeat this exercise with the code and find the clusters, and you can share, you can change the number of clusters. For example, you can use 3 clusters or 4 or 5, whatever you want. And another field that I am strongly, in this case, I am strongly exploring, and as I told you before, I am on my baby steps, is another kind of machine learning models, like light gradient boosting machine, like GBM model evaluation for predicting whether a customer is likely to cancel their subscription in the next 30 days. This is an application, and I got some results, and then I use the artificial intelligence in order to analyze the results, even though I didn't go too deep in the live gradient boosted machine model, but I tried to understand what is the interpretation. And obviously, if we see the result of ROC, we can have a 0.85, and obviously this is a very good result in order to distinguish between customers who will trunk or those who will stay with the subscription. This is in commercial, for commercial departments, for sales fields is very useful. And of course, as a conclusions, generative AI accelerates the analytical life cycle from data acquisition to insight generations. And this is the key, the effective prompt engineering is the cornerstone of a successful AI-driven analytics. And obviously, we need to take in mind the validation and ethical considerations because those are essentials for reliable outcomes. And obviously, to understand the theoretical background, the statistical theoretical background is something that we need to always take in mind. And we encourage to collaborate between human intelligence and generative intelligence, because this collaboration defines the future of analytics. And will the artificial intelligence take my job? I need to embrace the artificial intelligence in order to be more productive, in order to combine the human intelligence with artificial intelligence in order to have better results, and most of all, save times and be more accurate. And thank you so much for your attention. Thank you for having me. I will be very happy to connect with you on LinkedIn. Here you are my QR code, and feel free to ask some questions. I can read your questions now. Thank you so much. Here were some reference, and thank you. Now we are through our next speaker, Andrea Garcia. Let me introduce herself. Hello, Andrea.
Hello.
Welcome.
Thank you. I think you have a question in the chat.
Oh, really? Thank you. Thank you so much. We have time to answer that question for sure. Okay, yes, we are ready now. Okay, let me use the R. And yes, very good. Andrea Garcia Angulo is a professor of statistics at the Faculty of Natural Science and Mathematics at SPOL. And she holds a PhD in business economics with a focus on statistics and operation research from KU Leuven, Belgium. And her research interests include statistical modeling, model selection, and post-selection inference, where she has contributed to the literature with new methodological proposals. Welcome, my dear Andrea, and go ahead.
Thank you very much, Wendy. Let me share screen. Here we go. Thank you very much to everyone, and welcome also to this talk. Well, this talk is not, I'm not going to discuss any method, or I'm not going to explain the methodology here. This talk is more reflection on the role of statistics in this new generative AI era, especially in one specific task, that is data cleaning and data pre-processing before analysis. So that's why the name of my talk, Garbage In, Garbage Out, because I think that it's very important to understand that even though the big data era, AI era, and etc. is growing very fast and is actually helping us to do our tasks, the same challenge of preparing the data and having good data to start the analysis still is there. And now it only has new dimensions for statisticians to follow. So this talk is based on my experience, on my research. In my research, I was doing the effect, I was trying to analyze the effect of model selection in inference. And I used to use these diagrams to explain where the problems come from. And I'm going to use them now to explain you that in this data collection process now, we also have this, always we have this data preprocessing behind. And how everything that we do in the data actually has an effect on the results that we are going to obtain, and that we need to take care of them. We need to take this in account before continuing with the conclusions. So the traditional methods in statistics, especially when the focus were in inference or prediction, started with this approach that kind of follows the idea of the scientific method. Researchers usually had a set of hypotheses very clear. And based on this set of hypotheses, they will think in the model that can answer the questions, the research questions. And based on the model, then they will go and collect data on that, and finally do the analysis to produce some inference or to do some prediction. When the boom of internet, access to big data, access to computational tasks, and now the AI era, this process kind of have shuffled a little bit. Now it's in some fields, not in every field, but in some fields, now it's not really necessary to have your set of hypotheses really well defined to think about the model. Now it's more like you could have a general idea of a question in mind that you want to solve, and you will collect all data possible that can help you to analyze the question. In the example that Wendy used in the cells, for example, you have a set of data with several variables, and you will ask, in this case, AI, to tell you what's the data, what the data is about, and what can I do with that. That is something that is becoming more and more popular. We use the data to tell us which kind of models are better for that data. And based on that, we will try out several models, even if we don't do it manually. Even if we don't do it manually, the AI will do it by itself, or the machine learning, or any tool that we are using. And even if we are not aware of that, in this model selection and trying out, we are doing a lot of hypotheses behind, a lot of hypothesis testings. And based on this is that finally we decide in our conclusions, the analysis, the inference of the prediction. So this shuffle of this process that has been shuffled is not free on the effect that it has in the analysis or in the effect that it has in the inference. And that's where statistics comes and bring an important role. Because for this shuffling, we need to be aware of several problems of validity, problems of bias in our analysis, etc. So, but here is something important is missing, and is actually this data preprocessing that I think you can agree with us that before it was a very long task, and now thanks to the help of the computational era and the AI era, this can become a little bit faster. But of course, for this data preprocessing in between to be actually successful, for good results at the end and for good analysis in the end, we need to ensure that the quality of the input data is good. So what is this data preprocessing? So this data preprocessing can have several tasks, like data cleaning, which includes what do I do with missing values in my data, on how I handle very messy data that can include errors, outliers, etc. Then we also have the task of data integration. In data integration, what we do is that, well, sources now come from several, data comes from several sources, and for the use of warehousing, now we can adapt and join them all together for the analysis. We also have to take decisions in data transformation, what to transform, what not to transform. And finally, if we are going to use all of the data, we are going to make it a dimensionality reduction to process it better with the goal, all of these tasks, the goal of it is maximization of the information and accuracy. And with this maximization of information and accuracy that will be a good input for our analysis, the big challenge that I want to discuss, I know there are a lot of challenges in this, but the big challenge I want to discuss now is the challenge of avoiding bias. Because of course we do this cleaning of the data to avoid bias, but also by cleaning the data, we could also introduce bias. So I think that the key point here of the knowledge of theoretical statistics behind is to know where we need to be aware of what to do and what not to do to try to avoid the bias. So let's start with the first step of data cleaning in messy messy data with missing values, outliers. Well, traditional approaches tell us, okay, for missing value, you can do any kind of imputation. And from traditional approaches, you have like very basic univariate imputations like the mean, the mode, and is supposed not to introduce that much bias. You could also use some regression types, or you can use even more advanced multivariate methods like mice or deep learning-based methods. And what we need to be sure about for not introducing bias is that we are understanding the patterns of missingness here. And of course, that's not always easy to do, but we can use the artificial intelligence to help us to find these patterns. The idea, the statisticians are the ones that need to identify those key variables that are the ones that are key for your analysis. And with them, you will try to find which type of missing pattern is behind. For example, we have the missing incompletely at random, or not at random. And the problematic one is the not at random, because in the missing completely at random, if you have missing values, then you can do whatever you want. You can even delete them, and it should not affect your analysis. If you have missing it at random, then any of these imputation techniques will work well. you will decide based on the amount of data that you have and also the complexity and the correlation in the metrics that you have, which one to use. But if the missing is deeply related with your key variables, then there is a big problem. And then artificial intelligence cannot help you with that. And you is the one that has to have a good knowledge of the missing mechanism so that you can choose the best way to build that data based on what you have. When you have outliers in your data, well, yeah, you can say, okay, now there are plenty of options to deal with outliers, from very basic statistical and probabilistic methods, parametric or more advanced, not parametric ones, to robust algorithms that use cluster-based distance, that use, I don't know, machine learning-based methods, etc. All of them can help you to decide, okay, this is an outlier. However, I think the speciality of the statistics here is to actually try to think, is this really an outlier? And what is an outlier? Outlier is a concept, a very complex concept that actually will depend a lot in the context of your analysis. Sometimes extreme value is not an outlier because it's what you actually want to model. You are not interested in the average, but you are interested in the streams for the purpose of your analysis. And that's the key contribution of the statistics there, to identify actually, is this an outlier for my specific question that I'm resolving? Nowadays, the use of generative AI is becoming popular and is gaining a lot of terrain in use. This, for example, generative adversarial imputation networks to create syntactic data samples to identify errors in the data. So how does it work? Okay, you will need to provide a clean data for training, and artificial intelligence will generate syntactic data based on that follow all the patterns that it learned. So when it's compared with another data that could have errors in it, whatever error it is, even outlier or missingness or whatever, it will identify the pattern and it will identify the errors. So that's very good. However, it needs a clean data for training. And this clean data for training is this key statistical principle that remains valid always, that this clean data should be a representative data of the population that you're going to study. So how you guarantee that this is representative? Well, statistics is the base that tells you how to generate representative sample from a population that actually takes all the underrepresented groups into account for it. So that's the knowledge that you need to bring in this type of tasks. In data integration and data transformation, when the task is to use correlation analysis or to decide what to transform, like numerical coding, discretization, normalization, what to normalize or not, AI can help you with the decision on that. However, the key principle here is that you need to be responsible, that AI could understand in the prompts and the input that you give, could understand the type of data of variable that is included in every model. The type of variable, because the variable actually, the type of it depends on the technique, or the technique depends on the type of variable. For example, if you provide a column with a not clear name on it, and then it's only coded 1, 2, 3, and 1 means dog and 2 means cat, then it's coded 1, 2, 3, artificial intelligence would think, okay, this is numerical one, I will take a mean of it, and then I will have my 1.5. And this 1.5, what could be? Okay, yeah, it's the average between a dog and a cat, probably a very friendly dog, a very independent dog, I don't know. However, it's not correct. And the responsible of that is the knowledge behind that. The input needs to be very clear to identify the type of variables that can match with the available techniques that that respect the distances and etc. Finally, in dimensionality reduction, there is a special task here that can start with even very basic and classic approaches like PCA, linear discriminant analysis, factor analysis, and all their extensions. So you can also go for very deep learning methods on it. But what I want to stress on that is that some of these dimension extractions, what they are doing behind is that they are doing a variable selection. And in this variable selection, it's very important that we understand that if the data is telling me what variable is important, these are data-based methods, then there are some specific features that I need to care in the inference and prediction that I'm going to do if that's my goal. The feature is that I need to use any type of control of false discovery rate on that, because otherwise I'm going to inflate my type 1 error. And any type of them, I'm saying, okay, this is the classical data splitting for machine learning, that you have some data for training, that you have some data for selection. I will always suggest to have an additional set only for the final estimations and the final inference, if that's the case. Or you can also use more advanced things like post-selection inference, selective inference, or even go back to simultaneous inference. But that's important that you control, otherwise there is a problem of type 1 error at the end. So to conclude my talk, good data means good analysis, that's for sure. No algorithms can fix poor data, and the responsibility of good input is ours. Also, pre-processing now is becoming faster and faster with the use of AI and computer power. However, it's our responsibility to know what affects and introduce bias and how we can avoid it. And controlling false discovery error, validating variable types, and being sure of representativeness is our job, and there are good practices to be fair with the results. And finally, AI, when AI is guided by our statistical principles, then it's very useful to get meaningful insights and meaningful conclusions. Thank you very much. I can also answer your questions.
Yeah, thank you so much. Andrea, congratulations for your talk. And I would like to answer a question that is maybe for you and me, because it's from Meredith. Thank you for your question, Meredith. How can we be confident that the exploratory analysis results we receive from generative AI are accurate? That's excellent questions. That's a great questions, Meredith. In my case, I have the opportunity to compare ChatGPT Model 4 and ChatGPT Model 5. And when I started my exploratory analysis with ChatGPT number 5, it made mistakes because it haven't been trained. And this is the one principal key: train the model. And the next things that I do is compare different artificial intelligence like Gemini, Copilot, ChatGPT, and I do some and Cloud. Cloud is very good for analysis. It's very good for coding, and you can compare that. This is for my side. Andrea, would you like to add something about this question?
Yes, well, based also in what I said before, for this training, we need to be sure that the quality of data that we are providing, right? Otherwise, the model will learn incorrectly, of course.
Yes, of course, totally agree with you. Thank you so much, Andrea. Let me see if we have another question. Not yet? Okay. Thank you so much. Please, I would like to ask our next speaker, Catherine Morales, to open your video. Thank you so much. Welcome, Catherine. Let me introduce yourself, please. Yeah, thank you. Thank you so much. I have let me see here. Can you see my screen now?
Yes.
Yes, thank you so much. I have the privilege to introduce Catherine Morales. She is a data scientist with a PhD in applied mathematics, specialized in generative models and probabilistic method. She has worked across real estate, fintech, and climate risk, delivering models from research to production, evaluation, risk scoring, and anomaly detections. And she has also worked in a medical field with the European Cardiovascular Research Group, Stripborn Friends, and she has also collaborated with the women in data science community, contributing to knowledge sharing and mentoring initiative. Welcome, my dear Catherine.
Thank you, Wendy. So let me share my screen. Let me know if you can see my screen, please.
Yes, we can.
Yeah. So welcome to my presentation. Today I'm going to talk, sorry, I'm going to talk about generative Markov models in a context of semi-supervised classification. So let's start with what is a generative model, because nowadays we talking about every day about AI, ChatGPT, etc., but how it works. So in this context of from a probabilistic point of view, let's imagine we have different observations, for example, different images of famous people. So each image represents a sample from a unknown distribution. So we don't know that distribution. But in a context of probabilistic model, what we want to do is to choose a distribution with some parameters that we want to estimate. Here, especially in Bayesian probabilistic models, we want to introduce latent variables. What it means is we can extract some information that is hidden in the data. For example, we can extract information for only men or for the characteristic specific for women. So this is the example. And to do that, once we have this estimated model, we can recreate some samples from that distribution. So here, for example, we have different fake images that are examples of the learned distribution. So in Bayesian classification, let's imagine we have different observations. For example, here we have images of different animals. So in a context of classification, in this example, we want to design a label Y for each image. For example, in this context, we need to add the label of it's a cat, a dog, or a horse. Okay? Now, in a Bayesian context, what we want to do is to learn a probabilistic structure of the pair of observations, and in this case, the label, which is hidden because we don't know what is the label, and we want to understand how to obtain that label. So it depends. So the question is, what we have in our data set. Because of that, we can have different cases. So let's imagine we have all the images with each label: cat, dog, horse, and so on. So in this context, we have all the observations and the labels. So we are working in a supervised case where we want to learn the distribution from what we observe. So in this case is the images and labels. Now, if we are talking about a semi-supervised case, it means that we have some of the labels for some of the images. So here, for example, we have the image of cat, but here for this image and for those images in red, we don't have any information about the label, but we can explore the information where we have the label. So here the idea is to learn the probabilistic structure from what we observe, all the images, but with a subset of labels. Okay, so here, for example, we have this pair because we have the observation and the label, but in the second context, what we observe is only the image. And in the third example, we have the image and the label. And so let's imagine we have a lot of millions of images. And finally, the last case where we don't have any information about the labels. So we are talking about the unsupervised case, where the idea here is we learn from what we observe. In this case, what we observe is only the images. We don't have any information about the labels. So here we have the first case, the second case, semi-supervised, and the last case where we don't have any information, only the images. But here in our context, what we are trying to do is, instead of working in a static case, like each image, we want to work in a sequential case. What it means, we want to understand the idea of a sequence inside of the data. For example, let's imagine a video where each time step is each frame of the video. So at time t, for example, we have a label of the activity of the person inside of the video. For example, running, waving, boxing, walking. And what we want to do is to understand that probabilistic structure in a sequential context where we are taking into account the temporal or sequential context of the data. So now, instead of only observation, we have a sequence of observations, and we have also a sequence of associated labels. Okay? So now, in our work, what we want to do is to learn the general probabilistic structure, but considering the temporal dependencies. Okay, so in my previous work, we have different perspectives to work with this probabilistic model. The first one is the sequential generation. As we saw in the first slide, we can learn and we can generate some samples from the learned distribution, but also we are interested in sequential classification, where the label associated to the observed data are important for us, like in this example. So what is the starting point? In this context, we want to work with classical probabilistic models, for example, hidden Markov chains, where we can write the distribution of the observations as we have here, where we can introduce the latent variables. And here the idea is we can the observation of time t depends on the latent variable at the same time, and the latent variable, the probability of the latent variable depends on only on the previous one. That's is one of the characteristics of hidden Markov models. Let me, sorry. So that is the characteristic, the Markovian characteristic of hidden Markov change. Given the sequence of latent variables, the observations are independent, depends only in the at the same time of the latent variable. Okay, this is kind of theoretical part, but it's important because we want to propose a general framework that introduce that generalize all the previous classical and new models in this context. So for this part of for this model, we have different parameter estimation methods. When we are working with a discrete case, it means we are discrete latent variables. We have forward, backward algorithm, and where we have the continuous case, it means continuous latent variables. We apply the classical filter methods, so Kalman, particle, etc. So now, as the previous expositions, we introduce the idea of neural networks because nowadays it's really important. It's a big step from the classical model because we can extract features in a fastest way. It helps us a lot in a lot of kind of data. So here, because we are working in a temporal case, we introduce the recurrent neural networks, where the idea is we have the input information and we can add hidden layers in order to extract more deep characteristics. For example, in the first one, we can extract, if we are working with images, we can extract, okay, the image is like a circle. In the second layer, we can extract the characteristics of mouse, nodes, etc. And we can add more layers in order to extract more information, and at the end of the day we can have an output layer. That can be a label, for example, here the images and here the label if it's a cat or a horse, etc. So here we have a transformation of functions, and it's also a parametric function because we need to estimate the parameters of this neural network. So in this context, we propose that we can introduce a latent variable, but in this case it's not stochastic, so it's deterministic because the latent variable is the result of a known function, and the generative model in this context is given by the generative model is what we observe. So in this case is given by this distribution where we use the latent variable at the same time to compute the probability of the observation at time t. So the parameter estimation, we know that this is the backpropagation algorithm, so it's nothing so new here. And now it's okay. I have proposed you the classical inference, but also I introduced the neural networks framework. But the idea after that is how to compute or create a general framework for the previous models. Let me introduce one possible method, which is the variational inference, where it's normally is a solution where we in the cases where we cannot compute the maximum likelihood estimator because of we have a lot of, because of the high dimensionality of the latent variable, because the function is really complicated, etc. So variational inference introduce a variational distribution which help us to have a lower bound of the likelihood. So instead of maximize this expression, we maximize the elbow, which is the lower bound, which normally is easier to compute or easy to approximate. Okay, in this context, we are talking about the maximization of this expression with respect to the theta, which is the parameters of the observations, of the distribution of observations, and phi, which is the parameter of the new introduced variational distribution. Okay, this is a lot of theory, so sorry. So I don't gonna explain a lot of the details of this method, but the idea here is to understand we can use different tricks that are valid because we can have some proofs, the validation of those tricks, in order to compute without problem the elbow. Okay,
Thank
and
you,
after that.
Catherine, finish, please.
Okay, so yeah, sorry. Yes. So when we have all this information, what we want to do is apply what we present here in a context of semi-supervised case. So let's remember, it means we don't have any information for all the sequence. We have only partial information. So now the idea here is really easy. We make the difference between what we observe and what we do not observe, and so we rewrite what the expression I give you before. It's a big expression, sorry. That after that we can introduce the variational inference technique, but the idea is really simple. We, instead of use only the static variable, here we introduce the sequential case. And after that, we use the reparameterization trick and the convergence of matrix in order to compute the parameters.
Thank you so much, my dear Catherine. Time is over. And would you like to share the contact, please? Your contact slide. Yeah. Thank you so much. Thank you so much. And thank you for having all of us. Andrea, could you please open your camera? Yes, and spotlight all my speakers, please. Thank you so much. And this has been a great time with you, and thank you for being with us. And now we have the next session. Thank you.